I've talked about this before, but it bears some repeating. We think there are 4 moons of Jupiter that are large enough to be considered planets. I'm talking about Io, Europa, Ganymede, and Callisto. These 4 moons were all discovered by Galileo back in 1610. And they are so massive that if you were to remove them from Jupiter's gravitational influence, each one of these moons would make for a very decent planet. In fact, if you look at the combined mass of all of Jupiter's known moons, both big and small, it turns out that Jupiter's moon system is actually more massive than the planet Mercury. But let's not get ahead of ourselves, because we're here to talk about theories. One theory says that 2 of Jupiter's largest moons, Europa and Ganymede, were once Earth-like planets that got too close to Jupiter and got zapped into submission. And yes, I know that sounds like a crazy idea, but bear with me because this is where things get interesting. The 2 scientists behind this somewhat controversial theory are Robert Freitas and John Keefe from the University of West Florida. And their idea is based on a couple of observations that just don't seem to add up. The first observation is the fact that both Europa and Ganymede have Earth-like densities, which means that they are mostly made of rock and water, unlike Jupiter's other large moons Io and Callisto, which are mostly made of rock now. You might say that just because these 2 moons have Earth-like densities doesn't mean that they were once part of the Earth. And you would be right. But what's interesting is that these 2 moons also have Earth-like gravities on their surfaces. That's right. If you were to stand on Europa or Ganymede, you would feel something very close to Earth's gravity, about 90% of it, to be exact. Now, this is weird because both moons are about twice as dense as Earth's moon, which has a gravity about 1/6 that of Earth. So how can 2 objects be less dense than Earth's moon, but still have a similar gravity? Well, the answer is that they have to have a lot of mass. And this is where things start to get really interesting. Because if you assume that these moons were once Earth-like planets, let's say twice the mass of Earth, then their gravities would be close to Earth's gravity, even though they would be significantly less dense. This is because gravity depends on mass, but also on radius. And if you double the mass, you need to increase the radius by a factor of 2 as well, in order to keep the same gravity. But wait, there's more. According to NASA, the average density of Europa is 3.01 grams per cubic centimeter, while the average density of Ganymede is 5 grams per cubic centimeter. Now, I know that you're thinking, okay, if these 2 moons are so dense, why aren't they bigger? And that's a great question, but let me finish because here's where things get really cool. If these 2 moons were once planets, then they may have had a magnetic field similar to Earth's. And Jupiter's strong magnetic field could have ripped those magnetic fields apart, causing the moons to become unmagnetized and collapse under their own gravity. But wait, there's even more. It turns out that Jupiter's magnetic field is 20 times stronger than Earth's magnetic field. And according to the scientists behind this theory, the tidal forces caused by Jupiter as gravity compressing these Earth-sized planets would have generated enormous amounts of heat, enough to melt the entire rocky mantle of these planets, turning them into a ball of iron and nickel similar to Earth's core. So, to sum things up, if this theory is correct, then Europa and Ganymede were once Earth-like planets that had a similar mass, density, and gravity to Earth. They had Earth-like magnetic fields, and their interiors could have been similar to Earth's core. The only thing that would be missing is an atmosphere, which would make them more like Mars than Earth. But I guess it wouldn't be too surprising if they had an atmosphere, since the whole solar system was a bit more chaotic back then. However, despite the fact that this theory makes so many incredible connections, it's still highly controversial because according to our current understanding of physics, this just shouldn't be possible! There is no way that these 2 moons could have survived the trip around Jupiter without getting ripped apart by its gravity. But hey, this is science, and science is all about questioning what we think we know. Thank you for watching.